Question 6. Right, so we've got to sketch a graph. And we've got to sketch the graph of A minus mod X. So this is one where the modulus is around the X only. If you think about mod X graph, the mod X graph originally looks like that. So that's mod of X. Now the minus mod of X graph will look like that. So A minus mod of X, well, that's been shifted up by A, will look like that. And so that's the graph of A minus mod of X. It does say show on each sketch in terms of of each point where it meets or crosses the axes. So if you think about it for a second, right? So this on the right hand side we had, if I go back to my original mod of X, we had y equals X, and this other line is then going to be y equals minus X. But when you flip it over, when you go minus mod of X, this line is now y equals X, and this other line is y equals minus X. Right, so then if we shift it up by A, the right side leg, let's say, of my graph is going to be A minus X, and the left hand side is going to be y equals X, A plus X. And then we have to find out where each of those intersect the axes. Well, if you make X 0, then you get Y as A. If you make Y 0 in the left leg, if Y is 0, then X is minus A. And if on the right leg, if you do Y is 0, then you get X as A. So there's my intersection points for part 1. Part II. One separate diagram. So we're going to do another graph here. This is 3x minus 2a. Okay. So 3x minus 2a, and everything's in the modulus sign. So what you want to do is you want to sketch 3x minus 2a. So 3x, line y equals 3x has a gradient of 3. Minus 2a means it's been shifted down by 2a, and the y-intercept would be at minus 2a. But because it's modulus around the whole thing, what we do is we take everything that's above the x-axis and we reflect anything, so we keep whatever's above the x-axis, and anything that's below the x-axis we reflect that up. So this is now going to be going through 2a, and this part of the graph, the bottom part, disappears. That just doesn't exist anymore. Okay, we needed to find this intersection point. Okay, so that's when 3x minus 2a is equal to 0, and so that's going to be 3x is equal to 2a, and so x is equal to 2 over 3a. So these is 2/3 a. Okay, so in part B, we're asked to solve that. So let's see. So part B, find in terms of a, where a minus x is equal to 3x minus 2a, and in the modulus. And this is where it's really handy if you've written the equations of the individual lines on there. So if I actually go back to I did it for part I. For part II, this right hand leg, that was part of the original, so that was just 3x minus 2a. Now the left hand leg, that was a reflection of the line. So it was, in order to reflect it in the x-axis, we're going to times all the y coordinates by minus 1. So it's going to be minus 3x plus 2a. What I'm going to do is I'm going to draw the graph of part A on top of this. And this is where it's important that your gradients, that you represent your gradients accurately. So in part A we had gradients of part 1, we had gradients of 1 and minus 1, whereas in part II we had gradients of minus 3 and 3. So II gradients are steeper, so we're going to make this one really shallow, and it's going to go through A ignore my scales. This is A, and this is A, and this is minus A. And we can see that there are two intersection points, but both of them are on the right-hand leg of my first graph. So when I want to solve these, I'm going to do A minus X, which is the right-hand leg, is equal to 3x plus 2a, and this is finding intersection point number 1, which I'm going to label there. And then intersection point number 2 you're going to find by doing right hand leg of first graph is equal to right hand leg of second graph. And those are the two equations we're going to solve to find the intersection point. So let's just do that. So add the 3x over, so that's 2x, take the a over, you get a, so x is equal to a over 2, and on the other one we're going to take the x to this side, so 4x is equal to 3a, and so x is equal to 3 over 4a. And there's our two intersection points.